A very good morning to everyone. Today, we are representing St. Joseph English Medium School, Katwa, affiliated to CISC Council WB379. I, Samriddha Adhikari,
I, Rajdeep Ghosh.
I, Anushka Mondal,
are going to demonstrate the model on Tesla coil. A Tesla coil, which was invented by Nikola Tesla in 1891, is a radio frequency oscillator that drives the air-core double-turn resonant transformer to produce high voltages with low currents. Now let me introduce you to the principle of the Tesla coil. A Tesla coil produces output voltages up to several maximum volts depending upon the size of the coil. It has basically two portions, the primary coil and the secondary coil, and it works to achieve a condition called resonance. The primary coil emits huge amounts of current or electricity to the secondary coil, which further drives the secondary coil with maximum energy. This finely turned circuit helps to shoot the current from the primary circuit to the secondary circuit in a tuned resonant frequency. Now, may I request Anushka to introduce the working process of the model.
This is a miniature Tesla coil model. This model is made up of a PVC pipe. This right here is the primary coil, which is made up of a copper wire of 32 ohm. This part right here is the main part of the model. This is the secondary coil, which is made up of copper wire of 27 ohm. This thing right here is an aluminium ball, which is used for safety purposes. Do you know what's inside the PVC pipe? It's the circuit of the model, which is made up of the 2N2222A transistor and the 28 kilo ohm resistor. Now this model can be connected in two ways, either by an AC source of 9 volt adapter or by a DC source of 9 volt battery. Now Rajdeep, would you mind explaining the circuit diagram of the model?
So this is a typical circuit diagram of this Tesla coil. So here we have a 9 volt battery which is connected in two ways through an 18 kilo ohm resistor which goes to the 2N222A transistor, and another goes to the coil 1, which is the primary coil. So what happens is that first current from the positive terminal flows to the 18 kilo ohm resistor and it connects to the base of the transistor. The base of the transistor receives the current as a low intensity, and as a result the transistor becomes slightly on. Then current flows from the positive terminal of the battery to the coil 1, which is the primary coil, and when it reaches the primary coil it again transmits to the collector of the transistor. Then from the emitter it goes to the battery, thus completing the circuit. So what happens is that when current flows from the positive terminal to coil 1, it induces a magnetic force in coil 1 which either induces a charge or a voltage difference in coil 2, which is a secondary coil, and due to this result the coil 2 is, as it is connected to the base of the transistor, it develops a voltage difference, and this voltage difference flows to the base of the transistor, and thus it makes the transistor saturated, and as the transistor becomes saturated it cancels off from the circuit, and as a result the higher voltage accumulates in coil 2, which is a secondary coil, and as a result of high voltage accumulation in primary or secondary coil it emits sparks, and to reduce this spark we have used here a aluminum foil bulb. So when we are bringing a LED or any other bulb like CFL or something in front of it, the charge flows in square gap to the bulb, and thus the bulb starts glowing. This is the basic principle used. Now I will call Anushka Idi to demonstrate its use by using a CFL bulb.
Do you know Tesla coil is often referred to as a fantasy of physics? You know why? Let's find out together. Now this is a CFL bulb. If I bring this to close proximity with the Tesla coil, this will start glowing magically without any contact. Let's try it out, shall we? As I bring it to close proximity with the Tesla coil, this is glowing. But as I move it far away from the Tesla coil, the intensity or the brightness of the light in the bulb will decrease, and eventually it will stop glowing. This experiment can also be tried out using an LED bulb setup. Rajdeep, will you show?
Now I am going to demonstrate the use of this model using an LED board. So here you can see that it is a typical LED board. Here it is a modulator which is used to decrease and increase the intensity of current flowing in through this board. This is a transistor and this is a resistor, and these are a set of LED bulbs connected to this board. And here, right here, is a receiver. It receives the electricity, it means electrical connections from the Tesla coil. So what usually happens is that when we bring this board in a close proximity, the light starts glowing. And as we rotate it, the intensity of the current that is flowing inside the board increases. This happens because a spark gap is created in between the air, in between this Tesla coil and this receiver, and as a result the voltage that is developed in the Tesla coil flows from the Tesla coil to this, and as a result the LED bulbs are started glowing. This is a basic principle, means this is a basic demonstration we can show using a LED board. Now I would like to call Anushka Edi to explain its advantages.
Now let us know some advantages of this fantasy of physics. It allows uniform distribution of voltage throughout the winding coil. It also builds up voltage at a slow pace and hence no damage. Also, the use of three-phase rectifiers for higher powers can increase the load sharing tremendously. So overall, it's a great performance. Now let's know some disadvantages of Tesla coil. Rajdeep?
As we have seen that Tesla coil has a number of advantages, but it also comes with a number of disadvantages, like due to transmission of high frequency radio waves to our body. We possess several health hazards like skin burn, nervous system malfunctioning, etc. etc. Second is that it is very complex to build, and third is that to buy a very smoothing DC transistor, we have to incur a very high cost. Now, I will call Samrita to explain its applications.
As we have already come to know about various aspects which are related to the Tesla coil, including the working process, the advantages and the disadvantages. But at the present times, the Tesla coil does not need a complex large circuit for its use. Rather, small Tesla coils find a wide range of applications in various sectors. First of all, the most common use is aluminium welding. Secondly, cars use the Tesla coils for the spark plug ignition. Third, the Tesla coil fans are also created. High vacuum system cleaners are also found, and also the vacuum system leak detectors. In conclusion, we can say that a Tesla coil is a remarkable and memorable achievement and advancement by Nikola Tesla, which uses electromagnetic induction and radiation for its use. It not only demonstrates the principles of physics in an extremely exciting way, but also shows Nikola Tesla's genius in advancing technology. At the end, before closing, I would like to thank our mentor and guide and our physics teacher, Mr. Nilarko Ghosh, for guiding us throughout this demonstration. Sir.
Thank you for giving us the opportunity. We are representing St. Joseph English Medium School, Katwa. Thank you very much.